Okay, listen up. So, video ko to for the other class. First off, yung discussion ko sa video. If you have watched the acids and bases video, you remember that there are two definitions of acids and bases. What are the two definitions of acids and bases? Who has watched the video already? Diba? One starts with the letter A, one starts with the letter B. The definitions of acids and bases are Arrhenius and Bronsted. Okay, did you watch the video? Arrhenius and Bronsted. So, definition of acid. So, acids and bases can be defined. Actually, there are three, but I won't discuss the other one. So, the first definition is Arrhenius. When you say something is an acid, it produces H plus or H3O plus or protons. It just means the same thing, you know. But to simplify, we say it's H plus. If you remove the electron from a hydrogen atom, you'll just have a proton. That's why you can have proton. You can use proton, you can use H3O plus, because in reality, the H plus attaches itself to water. So this is not floating around in solution. Pero to simplify equations, I just use the H plus symbol. Okay? So an acid gives H plus in solution. So a base will just produce OH minus in solution. So that's the definition of an acid and a base. Okay? For Arrhenius. When you say Bronsted, the definition of Bronsted acid and base. So when you say something is an acid, what did I say in the video? An acid is something that is a proton donor. So a base is what? Okay, proton acceptor. So the simple definition of Arrhenius, so you just have H plus, this is the acid, or let's say we have HCl. This produces H plus Cl minus in solution. So hydrochloric acid or HCl is an acid because it gives us H plus in solution. NaOH will produce Na plus OH minus in solution. So that's the definition of acid and bases. But how about what if the solvent is not water? How do we define acids and bases? So that becomes more difficult, okay? So this definition covers the entirety of the different solvents, okay? So that means, let's say water, let's just water as a solvent. So NH3, so again, this is the Arrhenius definition. So NH3, for example, when you dissolve in water, you will produce NH4 plus OH minus. Okay? So, in so doing, the water will become the what? It will donate the proton, and NH3 will accept. So that this is what happens. Okay? So this is the base, and this is the acid. Okay? According to the definition of Bronsted. Now, in addition to that, we have the concept of conjugate acid and bases. So once you receive the proton, so this becomes the recipient. So this now becomes the conjugate base. Oh wait, sorry, conjugate acid. So the base here on the reactant side is the conjugate acid. Here, this is the conjugate base. Okay? So remember your Henderson-Hasselbalch equation. So you have the base over acid. Strictly speaking, we're talking about the conjugate base over the acid. So you might think, how will a base and acid coexist? It can if you have a weak acid or weak base. So you have a conjugate base and a conjugate acid in solution. Okay? So remember dun sa Henderson-Hasselbalch, conjugate base over the acid. Okay. So water dissociates, let's say, okay, water in small concentration. This dissociates into H plus and OH minus. Again, I'm simplifying. This is actually attached to another water. Okay? So water dissociates in small amounts. Okay? Even if the water is distilled water, there is H plus and OH minus in solution. Okay? So this is a balancing act. We call that equilibrium. So constantly you're splitting the water into H plus OH minus, and H plus OH minus combines to form water. So it's an equilibrium, okay? So we have what we call an equilibrium constant for this reaction. We call that the Kw. And the value for this is 1 times 10 to the negative 14. Okay? So there's a balancing act between the concentration of this one and this one. Okay? So basically, Kw is just the concentration of H plus times the concentration of OH minus. So this is a balancing act. So whenever H plus is very large, this becomes small. Whenever this becomes small, okay, if this becomes bigger, H plus is this becomes bigger, H plus is small. Okay? So all in all, so 1 times 10 to the negative 14 is the balancing the concentration of this will form the 1 times 10 to the negative 14 equilibrium constant. Okay? So when we apply negative log on both sides, so pag multiply natin, negative log 1 times 10 to the negative 14, negative log of H plus and OH minus. Okay? So what is the log of 1 times 10 to the negative 14? It is 14. So, negative 14 muna. So, negative ng negative 14 will be 14. And then take note, di ba, log, if you remember your math, log of x times y is equal to log x plus log y. So it's the same thing. So we can separate this as negative log h plus negative log OH minus. Okay? So what is this? Who remembers what this is? Negative log OH plus is what? pH. Okay? So this is where your pH plus pOH comes from. So the maximum number of either one is 14. Okay? So sometimes dun sa devices, lumalabas siya 15 or nag-0, pero yun yung range niya na ano. Kasi base siya dun sa kW ng water. So that's the main thing about this. So there's a balancing act. Whenever this is so ang range ng H plus concentration, it can be 1 times, it can be 1. Okay? So this becomes 1 times 10 to the negative 14. Or this can be 1, this is 1 times 10 to the negative 14. Pero nasa range lang between 1 and 1 times 10 to the negative 14. So, kaya yung, yun yung rationale kung bakit ito na yung limit ng pH plus pOH natin. Okay? Okay, I will discuss more sa lab. Basta, I just derived using the video. If you watch the video, I discussed this already. And I emphasized yung water dissociation para maintindihan nyo saan ang galing yung calculations nito. Okay? So, I will discuss more sa lab.